Part 2 of a one sample t-test for mu. Let's get going. Joe is doing a project for a sociology class in which he tests the claim that apartment buildings contain family units of average size of 3.3 people. That is the national average. A random sample of 64 families in this certain apartment building that he's looking at, okay, gives an average of 4.3 people per family per unit with a standard deviation of 1.3. So we have this national average of how many people live in a unit in an apartment, and then we have this apartment building, I'm assuming where he lives. They have an average of 4.3, so it's greater than, okay? Is this evidence that the average size of a family in this apartment building is different than the national average? Test at 5%, so that is that significance level. Remember, in the state, I'm looking for 4 things. I'm looking for your population parameter, your null hypothesis, your alternative hypothesis, and your alpha level. So let's write that down now, or type it up. Mu is equal to the true average size of a family in this apartment building. I'm not sure this problem was written perfectly, but I think we can get, the hang of what it should be. Our null hypothesis, that's that national average. So mu is equal to 3.3. On average, 3.3 people live in an apartment unit together, okay? Joe is wondering if that is different. This is how we can type not equal to. He's wondering if it is different at the apartment building that he's looking at. We have an alpha level of 0.05. Next, we have our plan. He states that it's a random sample of 64 families, so random sample n equals 64. He says 10 times n, so 64, is less than all families. N, okay, 64 is definitely greater than or equal to 30. That comes from our central limit theorem, just keep that in mind. And we're gonna do a one sample t-test for mu. Why are we using t and not z? We're using t because we don't know the population standard deviation, which is what we talked about in part 1. Okay, we have our state, we have our plan, and we are now ready for our do. I'm gonna go to the board for the do. Actually, what I'm gonna do first is I'm gonna run the test. So let's go ahead and run the test, and then we can go ahead to the board. So what's different about this problem compared to the first problem is I'm not given data, I'm giving statistics. Okay, I'm giving stats. Keep in mind this mu naught, that's your null hypothesis. So our null hypothesis is 3.3. Our X bar, that is the average, or that's your sample. That's what's describing the sample. So Joe, he found 64 families. He found on average 4.3 people live in a unit together. Okay, so we're gonna put 4.3. And the standard deviation that he found was 1.3. His sample size was 64. And our alternative hypothesis is right here. That's a not equals to. I'm going to go ahead and calculate. And now I'm going to go to the board. I'm running a little slow here. Come on, come on, come on. All right. Okay, so let's talk about this. You know what, I can't go to the board because my board is blue. Let's see if I can plug this in. I like using the board if possible because I have neater handwriting. Come on. We'll give it a second. Yay, we're back in business, guys. Okay, so in this do part 2, I want to draw my picture. It's the distribution now. I have my parameter. My parameter is my null hypothesis. This time it is a mu. Mu is equal to 3.3. Okay? We have an X bar. We have an observation. This is what we observed, or Joe observed as a statistician, 4.3. Okay? We're going to shade to the right. And now it is two-tailed. Why is it two-tailed? Because it is a not equal to for that alternative hypotheses, right? For that alternative hypotheses. Next, we need to have our standard deviation. Now, here is our SX. This is our sample standard deviation. That's what Joe found. 1.3. We need to divide that though by the square root of n, 64. Again, all of this information was in part 1 where I went slower for the formula, so on and so forth. Next, ultimately, what am I looking for? I want not zoms but tums. I want that t-score. T is equal to 4.3. I want work showing 4.3 minus, this is what we observed as statisticians, minus the mean of 3.3 divided by my sigma, which is right here, okay? I have my work right here, so I do not need to put it back in down there. I don't need to be redundant. What is my t equal to? That is 6.1538. And my p-value, please, please, please watch out for this. Look at this p-value. It has an e to the -8. Anytime it's -5, okay, or less than that, which kind of in your eyes think greater than, so -5, -6, -7, -8, you can say that that is approximately 0, okay? Because this is scientific notation where I have to move that decimal back 8 places. You could just say that that p-value then, anytime you have an e of -5 or anything more extreme than that, we say that our p-value is approximately equal to 0. If it was e to the -4 or 10 to the -4, you do need to move that decimal back 4 to the left, y to the left, because it's negative. Okay, let's move on. I have everything that I need. I forgot one thing in part 1, you guys. I'm sorry. I forgot our degrees of freedom. I'll have to say that in the live video in case people don't watch part 2. Our degrees of freedom, I will be looking for that in the do part. And that degrees of freedom is n-1. We have that from our interval as well. So our degrees of freedom are 64 minus 1. And again, forgive me for forgetting that in part 1. I will be grading that. You do need to write that down. And I'll reinforce that in live teaching as well. So what am I ultimately looking for, you guys, on the test when I'm grading it? I'm looking for your t-score with work shown. I'm looking for the correct t-score, obviously, and your p-value as well as your degrees of freedom. That's what I will be grading in the do step. Now let's go ahead and conclude. Okay, our p-value. So because our p-value in part 1, I reminded you how to do that conclusion. We look at our p-value, we compare it to alpha, and we make a decision about our null hypothesis. Are we going to reject it or fail to reject it? And then are we going to have evidence for HA or no evidence for HA? Okay, so because our p-value, which is approximately 0, is less than our alpha, 0.05, we reject the null hypothesis. We have evidence. The true mean, what is our context again? Let's look. Size of a family in this apartment building. Is not equal to 3.3. Again, this right here, guys, is our alternative hypotheses in context. All right, ladies and gentlemen, just a couple of friendly reminders. Make sure you know how to interpret a p-value. That's really important. The probability of calculating a statistic as extreme or more extreme than what we calculated, given the null hypothesis is true. That's an important piece of AP Stats. Don't forget, again, that degrees of freedom that I forgot to do in part 1 that I'll have to make sure that I get in there for anyone who's not watching part 2. Thank you for watching, you guys. Hopefully you learned some differences here with the two-sided and how to enter in the calculator if you are given statistics and not data. Have a great day, you guys. Bye.